Wind can have an impact on the livelihood of farmers. It dries out crops and erodes topsoil, but it also impacts farmers when they are applying chemicals to crop fields. To better understand that impact, researchers have brought the wind inside. As an electric engine revs up, Greg Kruger, a crop systems specialist with the University of Nebraska-Lincoln, explains the setup.
At the far end, we have an axial flow fan, and that creates an airflow. And then we've got an air straightener or a honeycomb that gets that airflow going straight down the wind tunnel. Over the course of 15 minutes. And we've set up a single nozzle sprayer inside this 4-foot by 4-foot wind tunnel. And then back behind that, we've got a scrubber system, which will pull out all the particles in the air that we've generated from running that sprayer system inside that wind tunnel.
The sprayer sends water through the tunnel. Kruger and his team are trying out dozens of nozzles, searching for the most efficient and effective chemical application methods. It starts with the droplet size coming out of the nozzle.
We know that the smaller the droplet size, the greater the drift potential. Those small droplets take longer to reach the ground. So anytime we've got an airflow that's pushing those droplets, if it takes longer to get to the ground, it's going to move farther from the point where it was released. So with our applications and what we do with the applicators is try to get them to use nozzles and pressures and spray solutions that are going to give them larger droplet size so that we get more of those droplets to the intended target.
Chemicals are designed to keep crop diseases and pests in check. The research is also investigating how much pressure is ideal for application. The more force used to apply chemicals usually means smaller droplet size.
We've done a lot of work in the field looking at different droplet sizes on the efficacy side. And if we get those droplets too large, a lot of times the pesticides don't work. So there's a sweet spot in there where we're trying to hit so that we don't have a lot of drift, but yet we're still getting the control from that pesticide that we want.
Near the fan in the wind tunnel is a honeycomb-shaped attachment which keeps the 15-mile-per-hour wind blowing as straight as possible. This introduces an element of physics to the tunnel and accuracy to the measurements. Each droplet sprayed in the tunnel is measured when it bends the light of the laser beam set up at the opposite end of the tunnel.
Anytime something crosses that laser beam, it changes the angle of that light that the lens picks up. So depending on how far that light bends, the lens sends that information to the computer, and the computer determines how big the droplet size is. Now, kind of counterintuitive, the more that light bends, the smaller the droplet is. So it's a little bit opposite of what we would generally expect. The precision is much better than even we could get with the naked eye. The diameter of a human hair is about 140 microns. We're picking up about 1/10 of a micron on that laser beam, so about 1,400 times smaller than what the diameter of a human hair is the size of the droplets that we're picking up. When a farmer goes out and purchases a product and sprays it on his field, he's purchased that product to control pest. So if we have drift going off the field, that's product that he's lost, and he's not getting the value that he paid for that product from.
The wind tunnel in North Platte is only the second of its kind in the U.S. For NET News, I'm Perry Stoner.